Okay, there we go. Number 1 right there. Boom. Number 3. Well, you can kind of cheat and just look at that angle. Angle ADE, when the radius hits the tangent at point D, the point of tangency, what angle does it create, Tristan? 90. You can kind of cheat and guess on that one, but basically it's always going to be 90 degrees. See how it looks like a perfect 90-degree angle? And B is angle BCD. Dylan, on angle BCD, what kind of angle is that? What's that kind of angle called if it's right in the middle of the circle?
It's the inscribed.
No, inscribed is on the edge of the circle. If it's coming from the center of the circle, it's called the central angle. What's the relationship between a central angle and its arc?
Oh, I know now. Oh, it's double.
Nope. Try again. Same. Central angle equals its arc. So B is 64 degrees. Okay, C, Carson, it says angle DAB. Do you guys see DAB in the picture? Looks kind of like that one right there. Carson, what kind of angle is DAB here?
I can't remember. I just know.
Dylan said it a minute ago. Inscribed.
Oh.
It's on the edge of the circle, vertex is on the edge. And what's the relationship between an inscribed angle and its arc?
It's double, so it'd be 32 at the...
The arc is double the angle, or the angle is half of the arc. Yeah, so it's 32. 32 degrees. Way to go, girls.
Thank you.
If only that had been your question.
Yeah.
We'll say the hard ones.
No, please. It's because we're on a different level than James.
Okay, number 5. These questions weren't too bad. Some of them actually were a little bit tricky. Do you guys remember these 5 through 9 questions, that circle to the right? If the radius is perpendicular to the chord, makes the 90-degree angles, then it splits those chords directly in half. That's one thing we learned. We also learned if the chords are the same length from the center of the circle. Ooh. Thank you. If the chords are the same length from the center of the circle, then they are the same length as each other. Like this would be this. If this is the same as this, then these two chords are the same. That's a big mess, isn't it? Also, and this is probably the most important part, if I draw this radius right here, what did I just make?
A right triangle.
A right triangle. And why might we want a right triangle? What did we use over and over again with the right triangles this chapter? Pythagorean theorem. Wrong. They're right. Okay. A squared plus B squared equals C squared. And this is a radius, right? And all radii in the circle are the same length. Like from here to here, here to here, they all have to be the same. Okay, anyway, that's what we learned about this stuff. Number 5 says FH, let's see, we're at Canyon. FH is 30. Maybe I'll give this to the girls. This one's not as hard.
Please,
Alright. Jaden, if FH is 30, how do we find HN?
cut it in half.
Cut it in half. So what's half of 30?
15.
15. I guess that's number 5. And then JL, what do you think about that one, dude? So in the directions it says, I didn't read them to you guys, but it says PM equals PN. So the chords are the same length from the center, so they have to be the same length. So if FH is 30, that chord up top and the chord on the bottom has to be 30. You got it?
Yes, if only you had given it to me.
Should have.
You should have.
You want to try 7 instead? Is 7 line? I can't remember. Okay, JL is 32. You guys see JL in the picture? It's the chord at the bottom. And it says PN is 12. I probably better draw this. Okay, it said this is 32. And it said this is 12, right? Okay, if this is 12, it looks like these two are equal, then this, don't you move out of there. And this has to be 12 right here, right? Okay, if this is 32, this is for you, Emily. If this is 32, how long is this right here?
Half of 32.
Yeah.
16.
16. Okay, now what's the question? The question is find PK. PK is a what in the circle? It's a radius. Okay, I don't really know how to find that radius, but I know how to find another radius. You guys remember that trick I mentioned earlier?
No way.
That is also a radius, right? Now why can I find that radius?
What's the radius?
90 degrees.
Because we got a right triangle. So, Emily, how do I solve the missing side of that triangle?
Which part?
We find an hypotenuse.
Oh, 16 squared plus 12 squared equals c squared.
Yeah, 16 squared, Pythagorean theorem, right? 16 squared plus 12 squared equals, I'll call it radius squared since we're looking for the radius. I believe that was,
Equals 100. The square root of that's 20.
yeah, remember I have to take square root at the end, so it's 20. Is 20 our answer?
Well, for PK,
Okay, 20 is the length of a radius, and PK is also a radius, so yeah, 20 is our answer.
then we need to find them.
Okay, it also asks us to find MK. Alright, let's go back to Canyon. Canyon, you see MK in the picture?
Yeah.
Okay, how can we find MK? Oh boy.
Subtract PM from. Yeah, subtract PM from PK.
Right. Okay, we just found out that PK was 20 long. That's what we just said. And we know this is 12 long right here, so how do I find that guy? 20, take away 12. That'll give left over. Huh? Congrats. I'll put that
You
guy
get
over.
a cookie.
That's a cookie.
Okay. Number 9. Archer. On number 9 it says find F and J, and then it says JL equals blah 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 and FH equals blah blah blah. What do I know about JL and FH in the picture? They're the same. They're the same chords basically. So I'm gonna set all that stuff equal to each other. All right. Any ideas, Archer?
Pull the x squared, cancel each other out.
Yeah, if we subtract x squared on both sides, what happens? They go away, which is good. Normally, now we had a problem like this a couple days ago with an x squared. Normally on x squared you move everything to one side of the equation and then factor. I don't know if you guys remember, like if it's x squared minus 5x plus 4 something, you factor it is to help you solve it. We did that one of those a couple days ago. But on this one, the x squareds go away, so we don't have to worry about it. It's just a normal x equation. So now what do I do?
Plus 5. Well, you can add the negative 5.
Alright. Get rid of the x's on one side by adding 5x. You don't want x's on two sides. You want to get all the x's to one side and get the x by itself, right? So now we're back to basic. 13x is 39. What's 39 divided by 13? 3. Is 3 the answer? Fortunately not, because they asked us to find Fn. You guys see Fn in the picture?
Yes,
It's half of FH. FH is this thing. So if I know x is 3, I can plug in 3 here. 3 squared is 9. 5 times 3 is 16. 9 minus 16 is negative 6. Sorry, 15. I said 16. 9 minus 15 is negative 6, plus 27 is 21. That is FH. But we want Fn. So we want half of this. What's 21 divided by 2?
10.5.
10.5. Now that is the answer. 10.5 is the final answer. We just have to do everything else to find it.
So we can't get decimals?
Apparently.
Are we doing like, or what number are we going to?
32, then we're doing 36 and 37.
The other class, we only did page 393 today, so. Yeah, we'll go through. Let's do this first page. Okay, number 11. All right, since we have so many breaks, this chapter got spread out a lot. Okay, 11 looks kind of like this. Okay, kind of missed. I mentioned this earlier though, when the radius hits the tangent, what angle do they make? 90.
No, it's a right triangle.
So we got a couple right triangles here. Okay, what else in these two triangles
Yeah, the sides are.
has to be the same?
The bases are the same, and then
What do you mean by base?
like the bottom
This?
two. Oh, those two and the bottom.
Okay, I don't know that these are the same.
You know that angle, that line is the same
Oh.
in the center.
Okay, they both share this side in the middle. You guys remember proving triangles are the same?
No,
Yeah.
that really proves.
Side angle, side, you remember all that stuff? Okay, I've got an angle here and a side.
And
I need something else.
you know those two bottom legs are the same because they're both radii.
Okay, these have to be the same because they're both a radius in the circle.
So would that be
That's what I
hypotenuse
said.
leg?
Okay, is side angle, is that one of them?
No.
Because it makes the bad word, right? Side angle?
No.
So yeah, it's HL. Yeah, you guys are right. And actually, I didn't read the question to you, but the question was, how can I prove that these two triangles are congruent so I can prove that these two sides are congruent? And the answer is HL, hypotenuse leg. So that's number, what number are we on? 11. HL.
And it's equilateral.
No, because, what kind of,
Right,
Yeah.
right equilateral?
no, not equilateral.
Oh.
Okay, 13. Oh boy. Okay, it says ST is, find ST. QR is X, so that goes there. Let me change colors. QR is X, then it says RS is 2X minus 4, that's this thing. And then it says QS, girls, is 2X plus 4. Okay,
Would you do the Pythagorean theorem?
right. What do I know about these three things together that make a right triangle? So Pythagorean theorem should work on it, right?
Yeah, so x squared plus 2x plus 4 squared equals 2x minus 4 squared.
You're a little bit off. Okay, which is the hypotenuse on this triangle?
2x
Oh, yeah.
Plus 4. This is the big side, it's across from the 90-degree angle. So this squared plus this squared should equal this one squared. This is a bit of a challenging one, folks. Sorry to say. Let's see how good our algebra skills are here.
Wait, hold on.
What do you guys think? What can I do first? No.
All of them. Can't you don't you have to do that?
Square all of them? Well, x squared, that doesn't simplify. How do I do 2x minus 4 squared? What does square mean? No,
Multiply by itself.
times itself. What kind of problem is that I just wrote right there? Foil problem. Yeah, first outside, inside left. What's first gonna give me if I multiply that?
4x?
4x squared. Okay, what's the outside gonna give me?
Negative 8. Or
Negative
minus
8x, minus 8x. What's the inside gonna give me?
Minus 8x.
Minus 8x. What's the last gonna give me? Negative 4 times negative 4?
Plus 16.
Okay, and then these two guys,
So negative 16.
negative 16x. I'm just gonna kind of bring that stuff up there. What about that right side?
Same thing.
Same thing, but those are pluses. So what's 2x times 2x? 4x squared. What's 2x times 4?
8x.
8x. Positive. What's 4 times 2x?
8x.
Positive. What's 4 times 4?
16.
16. Almost the same. What changed though?
It's plus 16 instead of minus.
Plus 16 in the middle. Okay, let's get rid of that.
So the two single x's decimal out since they're both, since one of them's a positive 16, one of them's a negative 16.
No, they're on different sides. That's not how it works.
Well, I mean,
Okay, there's a lot of stuff we can do at this point. What do you guys think? Any ideas?
Minus.
Okay, I heard somebody say minus 16. That's fine. We can do that. That gets rid of them, so that makes our job a little easier. What else?
Squared minus
If I minus 4x squared, that gets rid of that. Whoops. That makes it a little bit easier. So what do I have left so far? I have x squared minus 16, whoops, x equals 16x.
add 16.
Okay. We're getting into high level algebra here. We did do something like this in Algebra 1, but it's hard enough that I assume you guys forgot. When you solve an x squared equation, a quadratic equation, normally we move everything to one side and factor. So I want to get rid of this on the right side. So guess what I'm going to do? You might be thinking this is going to cancel out right here, but it's not. Yeah, negative 16 minus 16 is negative 32.
Did you say that?
Okay, I mentioned this earlier. I'm not sure if you guys heard me or were following or whatever, but you guys remember doing a problem like this a couple days ago?
Yeah.
And it was like, what goes into negative 5 that can add up to negative 4? It was like that, and then we said what x values make this 0 or make this 0. This is kind of the same, it's pretty close. This is 3-term factoring. This is not 3-term factoring, but we can take something out of both of these. What goes
An X.
x? And what's left if I divide an x out of both of these?
X and negative 32.
X minus 32. Okay, what x value could make this factor into a 0, and that would give us an answer? What x value would make this factor into a 0?
Positive 32.
Right.
I sneezed, but like I went.
Something's coming up. Just kidding.
No, it's not. I'm a good sneezer.
You're a good what?
I'm a
Sneezer?
good sneezer. Yeah.
Okay.
I'm not like
What about if there's an x in front? What could we plug in right there to make all this equal 0? If there's an x in front, what could I plug in right there to make all this
Negative
0?
X.
No.
Add 0, Katie.
0 would also work, right?
Yes, it
If I put 0 right there, what's 0 times blah, blah, blah?
would. 0.
0. Okay, but here's the problem. 0 x stands for like this thing right here. So can x be 0? No, that would be like nothing. So only 32 makes sense in this. All right. Is 32 the answer?
No.
What did you do that one?
You probably
How'd
want
you
to
like
plug
plug it
into
in?
RS.
Okay, it's asking for ST. ST is the same thing as RS in the picture. Do you guys see that? So we just need to plug this in for the RS thing, which is basically right here. This is RS. Same thing as this right here. So 2 times 32 minus 4.
60.
60 is correct. Now we're done.
Can you open the court test?
Is this the answer 64?
Is that gonna be on test?
Can we have some?
Definitely, that's number 1 on the test. That's the easy problem. No, I'm kidding. I might make it a bonus on the test. Though.
No, no one's gonna get that negative bonus for the
Yes, some people will get it.
Can it be
I will work
exact?
very hard. I will get that. Can you help on
Someone's gonna mess it up though.
Yeah, I helped the other class on 14, yes. Okay, 14. Let's give me some blanks. Okay, 14 says how many common tangent lines do 2 different circles have if they are tangent in the following ways? Okay, what does it mean for 2 circles to be tangent to each other? Yeah, well, if they're externally tangent, that means this. And do you guys remember what internally tangent
From
meant?
the circle,
It's on one
inside,
side.
Oh, that explains a lot.
Okay, so question A means how many tangent lines, common tangents can be drawn if you have externally tangent circle. So that's a common tangent, right?
Yeah.
Where else can I draw one?
The
On the bottom.
And then in the center.
So 3?
3.
I'll know you've got it.
So 14A is 3.
Would B be 1?
Okay, the B question is if you have internally tangent circles. You guys remember Mike Wazowski thing?
Yeah.
That was from this.
Yeah, we.
How many common tangents can I draw for these 2 guys?
1.
1 right there. 3 and 1. 15. Oh, we're doing fairly well in time.
Yeah, but we have to do the evens.
Fairly well.
I know. I'm thinking we can get done in 5 minutes. So I'll still leave you guys 15 minutes.
Thank you
Yeah.
so much.
And also this 2-day assignment. So.
16.
15, you mean.
What's my thing?
Oh, 15. Yeah.
Okay, 2 circles that are not tangent.
I think I know.
That have like
Uh,
external tangent and
Actually, let's skip 15. I'll do that one.
yeah.
No,
Okay. Yeah,
That was too good. Like,
So we
You
don't
just did it,
really
but you
know.
might not have done
we
it
don't
right.
have to do it, or you want me to go around?
Yeah, the three, no, 15's a
I
lie.
know what
The
it is.
answer's probably in the back, although they probably didn't draw it in the back. No, I think-
I have it on my notes.
So it could be
Yeah, so I was gonna do it right.
4, it could be
That's what I did.
But we don't have to.
0,
Yeah, that's exactly what I did.
and which one am I missing? There's one more example.
Could be.
Well, it's either inside or outside if they're not touching.
I don't know.
Oh, like this, could be like that. Then it would be 2 in that case.
But I didn't know the last one.
Anyways. Number,
So does that mean that tangent is just
Find
really
the arc
touching
length.
only
It's
one
like
place?
yeah.
85 arc of a circle.
Okay. On 16, it says find the arc length. I'm not gonna do this one, it's an even, but you guys remember the arc length formula?
Yes.
This is, we did a lot of this on the break worksheet. Yeah,
2 r pi parentheses beta over 360 parentheses.
yeah. It's the circumference formula times the angle theta over 360. Just gotta plug this stuff in. Remember when we plug stuff in on these formulas, we usually didn't plug the pi in, we just put pi on the answer, right? I think the book actually wrote it both ways, so if you do write the decimal answer, you'll still get credit, I guess. 17 says, find the circle's radius and the area of a sector defined by a 20-degree arc with a length of 3 pi. Okay,
Makes it too big.
if this arc is 20 degrees,
The inside is 20.
what's this angle right here? 20. So basically, our theta, our angle thing, is 20 degrees. Then it also says the arc is, let's say, 3 pi.
3 pi centimeters.
Okay, how can it be 20 degrees and 3 pi? What does that mean?
Second.
There's 2 ways to measure an arc. You can do it with degrees, like 20 degrees out of 360, or you can just measure it like with a ruler. Like this is like 9 centimeters or something. 3 times pi is about 9.4, so it's like 9.4 centimeters. So you can measure it like as an angle out of 360, or you can measure it just with like a tape measure kind of measurement. Like 9.4 centimeters. Anyways, this is the arc length. So I'm going to set my arc length formula equal to that. Right? And then so it's 2r, I don't know what r is yet, pi, times, I do know what theta is, that's 20 degrees. Dirty, equals the arc length. You guys remember these problems? We gotta figure out what r is. So how do I go backwards and find r?
Times
What do I do about this 2?
Divided by 2.
Divide by 2. So here's how I wrote it back when we did this assignment. I just crossed that out and put a divide by 2 over there.
And then the pi's cancel out.
Divide by pi would get rid of both those pi's. How about the parentheses there?
Multiply. Divide.
Okay, these 2 are multiplied together, right? So I also have to, just like I divided by 2, I have to divide by that. Divide by 20. 360. Okay, somebody plug that in the calculator.
I got 20.
Did this one say centimeters? Yeah, it did.
Yeah.
Okay. It also asked us, besides the R stands for radius, right? Besides the radius, it also asked us to find the sector area. Do you remember the sector area formula?
pi r squared beta.
Yeah, it's been up here on the board for about a month. Pi r squared times theta over 360. So I'm just going to plug those numbers in. What's my R?
22.
27, that's what we just found. So it's pi times 27, I don't need that, times 27 squared. What's my theta? Still 20. Oh, it's right there. Okay, again, remember we didn't usually plug the pi in, although you can, but let's get the answer that does not, or you don't plug the pi in the calculator.
Like
81 over 2 pi.
I have that too much here.
Good job. Anyway, that's the area, so I'll just put it over here. Area equals, this is the same thing as like 40.5 times pi, or anyway. If you plug the pi in, I think it came out to like 217 point something. What's that? That was the last odd actually. 18, let me look at 18. Find the arc
It's
length.
the same as 16.
Perimeter.
So we don't have to do 15?
No.
On 18, just find the arc length. Don't worry about the perimeter. Just plug it in the arc length formula. Well, I'm done. You are not done.
Can I go to left?
Yeah.
Can I go left? No, I'm going. Can I go left after Carson?
You can only go one at a time because
I
you
know.
guys make eye contact.
No, he's loud. He's. Never mind. Yesterday, I'm getting 9 over there.
Tell him to stop.
He's so loud.
Well.
Like literally, he was.
I don't think my nose. I don't think my nose hurts. Honestly, that he is low.
He is. We came back from chapter and he goes into the stall. And I see Steve going like this. He's like, ah.
What?
Dylan, that's not sharing public information.
Yeah.
Aiden walked in and just immediately walked out.
Mr. Jordan.
This is the thing. You can't share with others.
Mr. Jordan.
Carson chair.
Yeah, I'm scared to use
Mr. Jordan, I have a question.
When Carson.
You see Carson?
Yeah, I was